there's certain things, you can probably identify certain little things, little events in your life that were important. And this lesson today, although it's not a complicated lesson, ends up being a very important lesson all the way through into your calculus and beyond classes, because we're going to be talking about polynomial functions. And in general, when we talk about functions, there's some very large consistencies for certain types of polynomial functions. And we're talking in the broadest, most general sense. So we want to make sure that you understand these things, okay? It's really important, and I'm kind of frustrated that not enough people are participating in here. You want to change where your path is headed, start getting your hand in the air. Honestly, if you could start asking questions, everybody's grades are going to go up. If everybody is taking part in the class, everybody's grades are going to start going up, because you get to hear the questions that you're thinking and afraid to ask. I'll talk about details, but these details are very specific to a general type of polynomial. So let's take a look here. Polynomial functions, a couple of criteria that we have here. Your exponents, if it's a polynomial function, has to be a whole number. What's a whole number? No fractions, no decimals. Can be 0. Because a whole number starts with 0. And then goes to the right by 1. 0, 1, 2, 3, etc. So no fractions, no decimals, no negatives. Got to be a positive integer or 0. That's what whole numbers are. Okay? If your exponents are not whole numbers, doesn't mean it's not a function. And it doesn't mean that you can't graph it. What it does mean for us is that you don't call it a polynomial function. All your coefficients have to be real numbers. Now, for the most part, until last chapter, everything you could think of practically was real. What isn't a real number? Yeah, be specific. What is that? It's not irrational. Square root of -1, which is, well, we said it is, but what is that? Yes, SpongeBob, imaginary. Okay? So as long as it's a real number, a number that appears somewhere on the number line, you're talking about a real number. It doesn't have to be an integer. It can be a fraction, a decimal, a radical. Okay? All good. Just can't be imaginary. If it's imaginary, it's not polynomial. We have different names for different functions. You know the ones that I care about. The first 4 here, 5 here. If the degree is 0, we'll talk about degree in a second, it's called a constant function. If the degree is 1, it's called a linear function. If its degree is 2, it's a quadratic function, and a degree of 3 is a cubic. If you know those ones, those 4 right there, I think we're good. 4th degree is quartic, 5th degree is quintic, and etc. We just not that important. The degree of the polynomial function is the highest power on the variable. So look at all the variables, find the highest power, that's your degree. Now we would like, and we would encourage you to write what we are identifying right here as standard form. Standard form, another name for this that you may have heard before, especially when you learn factoring. What's another name for a polynomial function in standard form? What do we call it? Anyone? It has to do with the powers and how they're arranged. Anyone remember what you call it when you arrange them like this on the powers? Have you ever heard that term? Descending order? Yeah. Descending means you're going down. Descending order for your polynomials are from the highest power to the lowest power. And you want to make sure that you put all your polynomials in descending order. That is a habit you want to be in for everything you do in math. You never want to be in an order that's not descending. It messes things up. Okay? So descending order or standard form, very important. This is your leading term, your first term. The first coefficient is called the leading coefficient. Very important for us. The power in the variable in the first term is your degree. Nobody's going to write this. Nobody's going to write 9x to the 0 because we look at this picture. What's x to the 0? 1. So nobody was going to put a x to the 0. You're just going to write minus 9. And 9, or negative 9 if you want, is the constant. A constant term has no variable. Constant term has no variable, and it doesn't matter what the variable value is, that term will stay minus 9. And again, this table down here at the bottom, this table is telling you linear, quadratic, cubic, etc., and it gives you some examples. Be advised, really, all we care about is the leading term's power. You don't have to have 3 terms to be a quadratic. If it was just 2x squared, that's a quadratic. If it's 2x squared minus 9, that's a quadratic. And if you have a trinomial, that's fine too. But the highest power is what determines the name in terms of its degree. Does that make sense to everybody? Everybody in here has worked with polynomials before. You all have, whether it's a quadratic or a cubic. You've all worked with polynomial functions in the past. The things that you want to be able to identify, I'm training you up on being graphing. You guys are really good at it. Our classes are doing so much better now in graphing than ever before by making the list. 10 of you have said to me, I'm not doing that. I will not graph by making the list. Parent graph. Vertical stress factor, translation factor, that kind of stuff. 10 of you have said, I'm going to graph it my own way, and I'm fine with that. But the other 20 plus of you have said, oh, I'm down with that. This is so much easier. You learned your parent graph, graphing is easy. Same thing I'll tell you here. You want to graph polynomials, you do them any way you want. What I'm going to tell you is, these are the things you need to be able to identify. In your list, you're going to tell me what's the degree, what's the leading coefficient, and then based on that degree and leading coefficient, we'll have one other thing that we'll add shortly. But these are the first 2 in your list for graphing polynomials. Okay? So in this one, they're asking you what's the degree. So what is the degree for this one? Yeah, that's a 4. Everybody in the room should have that. And honestly, if you don't, it would be in your best interest to say, I don't get the 4. Why would you mean? How come it's not 6? Why isn't it 2? I thought it was 3. Okay? The first question was, is it a polynomial function? Yeah, this is polynomial. Why? Because the powers are integers and the coefficients are real. You don't really need to have an explanation. For me, that's if it is, it is. If it's degree 4, quartic, but most importantly right now, what's the leading coefficient? 1. And more important than the fact that it's a 1, that it's a positive 1. So leading, like in the honors classes and in this class, when we're doing our graphing, I want to know what's the degree, is the leading coefficient positive or negative? And then we'll talk about roots and then behavior after this. Is this, be careful now, is this one, the B question, is that a polynomial function? Okay, we got no's and yes. Let's look at the criteria. Look at the powers first on the variable. All the powers, are they integers? Yes. Does anyone see one that's not an integer in the exponent spot? How about all the coefficients? Are all the coefficients real numbers? In other words, is there a place on the number line that corresponds to each of your coefficients and constants? Yeah. So this one has to be considered a polynomial function because it meets those two criteria. Now I know some of you said no. Are you okay? Did I convince you, or does anyone see why it's might say, oh no, I still think that this is not? No? You sure? Any doubt you have, get it answered. Great question. Does it have to be in descending order? No. Only needs to be able to be put in descending order. So the order in which you get it doesn't matter. Just matters that you have integers for powers and reals for coefficients. That's okay. Like if this was a 7 and this is a 7, coefficients, perfectly fine. As long as they're real. You can even have an x squared and another x squared term. That's okay too, as long as your powers are integers. Just means they're not simplified. Okay, and of course you'd want to simplify. But if the question is it a polynomial? That's all we need. What's the degree of this polynomial? 2. Highest power on the variable is the 2. So if it's a degree 2, we just spent a whole chapter working with them. What do we call them? Quadratic. And you know the graph is going to be a what? Parabola. What's the leading coefficient on this? Be careful again. Pi. The leading coefficient isn't 7 because it's not in descending order. It's not in standard form. All right? How about C? Polynomial function?
No.
Why not?
Because the
Coefficients are all real. Is negative. So it's not a whole number. This is not a whole number. Therefore, this is a big fat no. Okay, why? Negative exponent. Can't have negative exponent. So we don't care, we can't define degree and type and all of that. How about D, polynomial function? Yes, no,
Yes.
yes,
Yes.
yes.
No.
We don't know.
We don't know X.
Maybe. Okay, let me go through the definition again. Let's do the coefficients first. Coefficients and constants have to be real numbers. Are the coefficients and constants real numbers?
Yeah.
Coefficients are, the constant is 2 to the x. Okay? That means the variable x is in the power position, which means not going to be a polynomial function because x would have to be, in order for that to be a polynomial function, x would have to be
Real number.
a whole number. Can you think of a value for x where it wouldn't be a whole number? Huh? Like -1, a half, 2/3, square root of 7. All those values for x would invalidate this being a polynomial function, so this is no. You have a variable in the power. Can't have a variable in the power spot. Okay? Yep.
If it gave you a problem like that and then said x equals 2, would it be considered a polynomial function?
Nope. Then it would be a constant function because if x is 2, then this is 2 plus 4 minus 0.6 times 32. You're going to get a number. Okay?
So I have a question about, so we have to write down like polynomial function, yes, no, as a sign or.
Okay. We're going through, is it or isn't it? Why are we doing this? Just so you know. You can't possibly think this is a test question. Right? It's not. This is, do you know it? or not. Okay, I just want to make sure you're clear what is and what is not a polynomial function. That's all we're doing.
What if the variable is 0?
If the again, variables can be, by definition, any real number.
But would that make it a polynomial function?
Well, again, if the variable was a 0, you would get a number on this side, and you no longer have a polynomial function because you don't have any variables. You can't assign a value for your variable. You have to look at it in variable form. Does that make sense?
Yeah.
So it's not what if, it's here it is. No variables in the power, no way.
It says X
It
is a whole
never
number.
says that. Okay? Remember, we're doing a function, y equals 2x plus 5. Right? You're never saying x is only 3. X can be any real number. Okay? And if you do assign a value, you definitely don't have a function. Because you're plugging in some number for x. It no longer has a variable, so it can't be a polynomial function.
What if I just say that it's equal to it and you know that?
But again, you're what ifing. Okay? Not in a bad way. I'm just saying, what if they said, if you have to say what if, then the answer is no way, no how. Okay? This is polynomial. It's take it as it is. You never are dealing, nobody ever restricts your domain to determine that it, oh, well, if we did this, then you would say, yes, it's definitely a polynomial function. But that's not the case. Never going to be the case. But great idea, it'd be kind of cool. See if you can do these 3. You don't have to write them down unless you can write them down if you want. All I want to know is, can you identify, is it a polynomial function or not? And then degree and leading coefficient. Just take 2 minutes. Haley, how about the first one, polynomial?
Yes.
Yes. Degree? So what kind is that? Linear, very good. If you were to graph it, you would get a line. And the leading coefficient? Excellent. So you can see it's not given to you in standard form. We don't really care if it is or isn't. Nick, how about number 2?
It's not.
It's not. Why not?
Because it's a negative.
It is an unclear pronoun reference.
The exponent negative.
Yeah, negative power, no way. Okay, so we can't have a negative power. How about number 3? How about number 3? Right?
It's yes.
It is yes. Why is it? We got reals and integers, good, or wholes. How about degree on that one? 2. So if it is a degree 2, what type?
Quadratic.
Quadratic. And what about the leading coefficient?
6.
Sorry. Was it a 6?
Yeah.
Excellent. Okay. Any questions on those 3? Anything you're not clear on? This little quick analysis of a polynomial function is huge when it comes to graphing. Now, we're going to be very limited on what we do in terms of graphing today. I'm going to give you the first component of it, and then we'll deal with the second component tomorrow. Okay? So, here's a polynomial function, and they want to know what's the value of that function when x is 3. See if you can figure it out. If we're doing direct substitution, let's see what we get for answers. Allie, did you get an answer?
No.
You don't have an answer. Christian? 23. Can anyone say they got that?
I got negative 31.
Okay, let me write some things down. So 23, negative 31. You got 23 also?
23.
23? Anybody different? You got something different? Ken, you got 23? So, a lot of 23s. That sounds good. Who got the negative 31? Say, I'm not bailing on you. I'm just. This is all I need to see from you. And I really want you to start utilizing your calculator to do things like this. Okay? On your calculators, except for a couple of you, you can enter this whole thing in one shot. Okay? 2 parentheses, 3 parentheses, raised to the power of 4. Minus 5 parentheses, 3 parentheses, raised to the power of 3. Minus 4 parentheses, 3. Plus 8. You should almost all be able to put that in your calculators. There's only a couple of you who can't. And then all you have to do is press enter and get 23. So all I would need is that the y is 23. Explain to me what we just figured out.
Like minus equals 3.
Okay, what does it equal? And what does that tell us? For this polynomial function, somewhere on this graph, we would expect to see the point 3, and it's off my chart here for some reason. So we would expect to be able to see the point 3, 23 on this graph. It should be, oops, right in here. Look at that. Now you can't see the whole graph, that's not the point. We don't. You can't see the whole graph. There's stuff missing here that you can't see. Okay, it's just the graph is either too small or not tall enough, not wide enough. Some way, somehow. And we'll get to the why. We don't care right at this moment. What I want you to get from me right now is that when x is 3, y is 23, that's a point on the graph. That's all I care about. And that's all we care about today. If you don't know synthetic substitution, which I don't expect you to, this is one of those things where I look at these people who invent stuff like this, and I go, man, how did you ever come up with it? And it is so cool that you did. Synthetic substitution is your get-out-of-jail card for polynomial functions. And it's your get-out-of-jail card in so many ways. So I'm going to show you how I do this process. And I don't use this at all. Mine's just a little bit different organization. What you're going to do is take your polynomial in standard form. It must be in standard form. And you're going to write down every coefficient and constant of every variable. Blush. Okay? We're going to do every coefficient and constant. And I'm going to just get this out of here because this is not how I do it. So when I look at this, I'm going to have a 2. I'm going to have a -5. I'm going to have a 0 because there's no x squares. And that 0 will be what we forget. You'll forget it a lot, especially at the beginning. But remember, descending order, 2x to the 4th, 5x to the 3rd, 0x squared, minus 4x plus 8. You have to have every power represented in order to do synthetic division or substitution. So 2, -5, 0, -4, and 8. Then we're going to just draw a line here, a separating line. Down here I put a L box like that, and over here I put a reverse L box. Okay? Why are you making that face, Christian? You good?
Yeah.
It's confusing?
Yes.
Okay, so then let's stop. So once you get this set up, bring the first number down, multiply the number here in the L box, this 3, times this 2, and write that product right here. 3 times 2, 6. What does it say to do? Add down. 1. And then multiply again. 3 times 1 is, write it in the next spot, add down, 3. Multiply again, 9. Add down. 5. 3 times 5. Add down. Dun, 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 dun. Or ta-da. Or some ta-da is good. Ta-da. It's like magic. It's whatever they tell you to synthetically divide. Just like on the last one, I told you the direct substitution. On this one, same problem, but doing direct substitution. Okay, we could do direct substitution all day long. You're good at it. But how many do we really need to do? This is going to be what we really need. Yes, sir?
So the 23 is the solution?
The 23 is the function's value when x is 3.
Okay.
Just like direct substitution. When x is 3, the function's value is 23. It's an ordered pair. Same, right? Which we would hope that, right? This is just a better, faster way to do it.
So do you have any idea how they came up?
Google it.
Is there a reason that you have to have the x?
The x.
At the 0.
Say it again.
You added a 0 for it.
I didn't add a 0. I put a placeholder. Okay? So the placeholder is nothing different than when you say 1,001, you put 2 zeros where the hundreds and tens are because there aren't any, right? It would be very confusing if we just did that and meant 1,001. You need to know that. So I'm telling you on day 1, example 1, you have to have every variable power represented from the degree down to the 0. So when there isn't a square, you put a 0 to hold the squares. Okay? Does that make sense? Or not make sense?
It does. I was wondering, like, if there was something else we were going to do later that needs the 0 because...
Like, would you ever write 0x squared? Is that what you're getting at?
No, it's like, this doesn't really need the 0.
It absolutely needs the 0. Here's what happens, and you guys are not going to put the 0 in. If that 0 is not there, this 3 will be right here. And when you add down, you're going to get -1. And when you multiply, you're going to get -3. And when you add down, your answer is going to be a 5. And everyone in this room, myself included, will make that mistake. More likely than not. Okay, so some people maybe won't make it because they're really paying attention right now. But if that 0 is not there, you'll get the wrong answer. You seeing that?
So are you better off using direct substitution?
No, you need to know how to do synthetic division. It's easy. You don't need a calculator for this.
Oh, is that what you get?
No, you just need to know how to. Let's just trust me on this, and you'll eventually you're going to go, oh, I get it. Trust me.
Once you get into like outrageous power, just 20.
You don't.
something with-
You're never going to. Not going to happen. What? Okay. Certificate show. One of us will do it. You got it. Stay dry. Are we good on this? All right. Let's see. All right, so let's try this one. We're going to do synthetic division. You can try it right now. This one's a little bit different. All right, so real quick, we have a 5, 3, don't forget this is -1 and 7. Not a +1. Okay? And for x, we're putting a 2. Okay, in for x, we're putting a 2. 5 down, what comes here? 10. 13. Careful on that one. And then 50. There you go. So that means f of 2 is 57. Now let me just plant this for no reason right now. No reason right now. you have x equals 2, right? What factor, what binomial, if you were solving for x, where did x equals 2 come from above it if you were solving? What was above that? What factor and what did it say?
X minus 2.
Equals
0.
0. Okay? That's going to be important to us later. It has no value to you right now, but we're connecting dots later. Okay? Do you need to do another one or are you good? Good? Everyone feel good? Synthetic division is really fast. You'll get really good at it, and the only mistakes you're going to make will be what? Well, yeah, that. So what do we call those? Silly mistakes? Careless mistakes? That's the only stuff you're going to have as a 20. Now, we're going to talk about what does the graph look like? And right now, all I care about is what we call end behavior. Okay? End behavior. So we're going to look at this, and I'm going to add a slide in here for end behavior. Bless you. So for end behavior, right? There's two things that I'm going to want you to identify. First, I want you to identify what the degree is. Okay? And there's two different types of degrees. There's an odd degree or an even degree. If you have an odd degree, the next thing I want to know is the leading coefficient positive or negative? So if it's an odd degree, leading coefficient of positive, your end behavior is going to be up on the left, down on the left, up on the right. Your graph, if you have a degree that's odd, positive leading coefficient will be pointing down on the left, up on the right. What happens in the middle right now? Today, I don't care. Okay? The end behavior, down on the left, up on the right. That's all I care about. If your degree is odd, if your leading coefficient is negative, it flips it. Your end behavior will be up on the left, down on the right. So from left to right, when you're looking at it, your graph will start pointing up on the left and end pointing down on the right. What happens in the middle, all the ups and downs? I don't care today. I will care, but not today. Okay? Odd degree polynomials work like linear graphs, linear functions, and they work like slope. If the slope is positive, how does a linear graph go from left to right? From left to right. Down to up. It's increasing from left to right. That's the same thing that we're saying here. We're going to increase from left to right. If you have a negative slope, you're going to decrease from left to right. That's only true when it's off. If your function has an even degree, if your function has an even degree and a positive leading coefficient, then your end behavior is going to be up and up like a touchdown. If you're positive even, the ends will be both pointing up. That's all we care about today. Up and up. And as you can imagine, if it's a negative leading coefficient, even, the end behavior should be down and down, like a rainbow. Okay, both of them will be down. Okay, that's what the next few things are going to tell you again. Odd, leading coefficient positive, down on the left, up on the right. All I will ask of you today, when you are at a graph, you don't even need graph paper. Just go like that. Degree, 3. Leading coefficient, positive. End behavior. This is where you say it. Down on the left, up on the right. So all I want for the graph is this. Don't even worry about what happens in between. Today. There's only one more thing to add, and we just have a little bit of tweaking to make that work for you. That's all I need from you. What goes in there? Oh, it's locked. Yeah, let's see. Oh, he's got just a empty white box there. That's good.
Maybe it's so you don't pick the other one.
I picked the wrong one. There we go. So again, we look at our list. Degree is 3. Leading coefficient is negative. So your end behavior is up on the left, down on the right. We say from left to right, up, down. So your graph, all I need from you on the graphs is this and this. That's it. Too fast? Good? Too slow, sorry. One of our rocket scientists is being held back. Degree? 4. Leading coefficient? Positive. End behavior has to be up and up. That's all. I don't need the wiggle, just the end behaviors. Start making that list. Degree, leading coefficient, end behavior. Work on that list, because if you have that list down and it takes literally 3 seconds to do, you're going to find this is fantastic. Degree 4, leading coefficient, negative, end behavior, down and down. That's the important thing today. The picture, we don't care what happens with the wiggles. We just want to know that it's down and down on the ends. Okay. So, here's 6 of them. Here's 6 of them. We'll go from left to right, A, B, C, left to right, E, F. I want you to make the list. I want to know what the degree is, what the leading coefficient is. Obviously, you know the end behavior. So you should be able to tell me what the degree is and the leading coefficient. Just write all 6 of them down real quick.
Oh, like that?
All right, let's flip the card and see how you did. This one should be what? Odd and negative. So that's an odd negative. This one, even negative, right? This is pointed down, so it's even negative. This one's even positive. Odd positive. And odd positive. Very good. Anyone have a question on any of these? Really? Get a little more RAM in that computer and it'll be able to handle 6 of them. Everybody good on those? Alright. Describe the degree and leading coefficient of the polynomial function. Again, this is the same drill. What is this? Odd, negative. If you're not seeing it, you got to ask the questions. Okay? Then just do that. Give it a wave because I saw that. look at the ends. The end is up on the left, down on the right. So they're going in opposite directions. That makes it odd. Any of this, odd, odd. Evens have to be a touchdown or both down. I thought that's what soccer refs did when they scored, but I was told that's not true. But the referee does this? Yeah, well, I'm talking, I thought the soccer refs. So if you're in different directions, you're odd. Touchdown or both down, that's even. Then you look at it from left to right, think about this as slope. So we're going down from left to right, that's a negative leading coefficient. Okay? If they were both up, touchdown, that's good, that's positive. Even positive. If they're both down, like a frown, both negative. Okay? So that's even negative.
So, so it's kind of really only where like the arrow's pointing.
We don't care anything about the wiggles.
Oh, okay.
We only look at the end behavior.
Oh, okay.
Okay? We'll talk about how do we get these wiggles in the next couple days.
Okay.
But you only need to be looking on the graphics at literally right here and right here. We're up on the left, down on the right, that's odd. And because you're up on the left, that makes it a negative.
Okay.
So if it's a linear function, it would just be as simple as like slope.
Oh, what a linear, you would say it's odd, negative, or odd, positive. It's no different. If you drew a line, you would say it's odd because the end behavior is opposite directions. And from left to right, this is up on the left, down on the right, that's negative. And it is the slope, but that's not what we're evaluating. We're just evaluating which way they're pointing. Okay. Don't overthink.
Yeah, what if, like,
Here we go, a what if-er. Go ahead. What if?
y was equal to 0 and the linear, like y equals 0, so it's
That's a horizontal.
yeah, well, so would it be positive?
Yeah, that's called a constant function. So your end behavior is not going to help you, and that's not what this is really designed for. Okay? You're feeling pretty good about yourself, aren't you? Hey, I messed with them. I got them. All right. So tonight they're going to ask you to graph. This is, again, all I expect from you. All I care about is end behavior tonight. You don't need graph paper. I want you to tell me what's the degree. What's the leading coefficient? And the end behavior. Up on the left, down on the right. So all I will ask you to do, let me get this thing back out of here because we just don't do it. All I'm asking you to do is this. Here's your graph. We are not going to plot points. Okay? We do not have time for that, and we are way too smart for that. We can outdo this if we know one more thing, which we'll learn tomorrow. So tonight, regardless of what the directions tell you, on the graphs, this is all I care about. Okay? Keep it simple today. Somebody had a hand I missed? I did?
Is it that when you get X?
It's not, are you good to hear?
Yes, I am.
Then you can just be in suspense. You're one of those guys who reads the last page of the book first, aren't you?
No,
Yeah.
no.
Look, lying isn't admitting you have the problem. First step to solving the problem is admitting you have the problem. What's the degree? 4. Leading coefficient. End behavior. Up and up and up. So your graph, all I need, bam, bam, done. Keep it simple. Keep it simple. Yes, sir? Well, what is the leading coefficient?
What do those bars have to do with anything?
What are these?
Yeah.
I don't know. This is Stedman added these to the presentation today, so.
Hopefully we wanted to plot one.
It's really for synthetic division,
Oh.
for figuring out plotting points. So rather than do direct substitution, synthetic is way faster, and you would plot some points to figure out what the graph's gonna do wiggle-wise. We're not going there. I'm setting you up for honors. The honors kids would never plot random points. Okay? I want you to plot some, in this case, 4 specific points, and I'll tell you where they are tomorrow. Okay? So take a look at your calendars. You are on, what is today? So you're looking at homework number 19. Homework number 19, section 2. Hold on. So it may or may not be that assignment. Check homework 19.